Could I get a student to first read the complex conjugates theorem for the class? Just to hear it, see what it looks like, how it sounds. Who would like to volunteer to read that for us? Complex conjugates theorem. Oh boy. Yes, please.
Conjugate pairs theorem. Suppose f is a polynomial function whose coefficients are real numbers. If r equals a plus bi is a zero of f, the complex conjugate of r equals minus bi is also a zero of f.
Okay, so that's all it says. That's what we were discussing before class ended for the break. If you get 2 plus 3i and you list a 0, then automatically 2 minus 3i is a 0. That's all that complex numbers conjugate theorem tells me. Now, who would like to read the intermediate value property so I can close this down? And then I have an example. I need a volunteer. Jonathan, go for it.
All right, intermediate value theorem, let f denote a polynomial function. If a is less than b, and if f of a and f of b are of opposite sign, there is at least one real zero of f between a and b.
Now, here's the benefit of that intermediate value property. You're going to get carried away. You're going to be nervous doing all this. I'd be nervous. Where all of a sudden the professor gives you a p of x, and I don't think I'll go too crazy on you. I don't think I'll give you an x to the 7th or an x to the 6th. That would take you forever to find all those zeros. But you still go crazy because you got to start testing and testing and testing until you find something to work. Now, Jonathan, here's where I'm going to close this down. I'm going to jot down a function that I sat here and created while you guys were on break that I thought would be so nice to sort of close this down. Okay, let's start this as part 1. And p of x, I created it fairly quickly, so it works. Looks like this. 6x cubed plus 3x squared subtract 33x subtract 30. Let me step back and look at it, make sure it's popping down correctly. Looks good. All we're going to do is find the zeros. Try to find the zeros. Now I'm going to help you out of this one. Rather than asking you for guesses, I'm going to set this up for you. Guys, how many zeros am I expecting? 3. Now if you want to go through Descartes' rule for before you get started, see how many of those 3 should be positive, how many should be negative, the remaining are imaginary, you could. I'm not going to go through that. Now though, here we go. If you use P over Q, rational zeros theorem. And the P should be a factor of that constant term. You gotta write those factors first. Let's see if you guys will agree with this. I think those are the only factors of a negative 30. I will not leave anything out. The Q, you got list all the factors of your leading coefficient to 6. And I'll write those like this, 1 and 6, 2 and 3. And then what you're supposed to do, you're supposed to start testing. You're supposed to come up with the different combinations and start testing. Now, I have chose these. I'm going to show you what I tested. I chose these for a reason. Guys, suppose on the side here, nice synthetic, I test 2 first. Oh, by the way, would 2 be a possibility to begin with to be tested? Yes, 2 here, 2 over 1 gives me a 2. So 2 is a possibility. I don't know whether it's going to work or not, but here goes. By synthetic, I'm going to jot down my coefficients. Just open all this down. come back and look at it, we're hoping to get a zero. Here goes. Make sure I have all this copied out correctly. 0 here, 6, 12, 15, 30, -3, -6, -36. Guys, someone check, do that correctly, I did it quickly. Do I sure enough end up with a -36 on the end? Yes,
For the P, can't you put 3 and 10?
very good now?
Plus or minus 3, plus or
Oh,
minus
did I leave
10?
something out? Oh, thank you, plus minus. Thank you. He says, don't leave those out, 3 and 10 would also work for 30. So we'd have a lot, thank you, because we have a lot of choices here. Now I'm choosing the choices for you, to point out something. Guys, 2 would be a possible 0 to test. I tested 2, and please tell me, is it -36? Did it work? No. Here's one benefit. It didn't work. That does tell me that when I tried 2, I got -36. It's not one of the zeros. But guess what that tells me? That tells me on the graph of this, if I should graph it, which I'm not going to do, if I should graph it, guess what? I'm guaranteed this is on there. That point's on that graph. It's not 0, it's not on the x-axis, but it's on the graph. So the synthetic, go ahead and finish it up and see what's on the end, and that sometimes it's beneficial to see what that is. It may not be what you're looking for, it's not a 0, but it tells me something about the graph. It's on the graph. Now, I tested next. Didn't work, so I'm still testing. I tested a 3. Let's see if 3 is a possible, yeah, 3 over 1. They give me that 3 times 10. 3 over 1, that's another possibility for a 0. I'm gonna test it. I gotta go back to the original. Nothing's worked so far. And I get this. Now, careful. 0, 6, 18, 21, 63, I think that's 30, 90, 60. I did that quickly. Did it work? No. But it tells me that when I tried 3, I got 60. I didn't get a 0, which I was hoping to get. I got 60. That tells me at that point also, out 3, up 60, it's guaranteed to be on the graph of this. That's the benefit. You're guaranteed 3, up 60 will be on there. You're also guaranteed out 2, down 36 is on that graph. There's a little benefit there. Now, just out of curiosity, I'm not going to graph it. If you plot this point, out 2, down 36, is it below or above the x-axis? Out 2, down 36. Below. If you plot this one, out 3, up 60, on a grid, is that above the x-axis? Now, a polynomial function is supposed to be continuous. That's the word they love to use. It's supposed to be nice and smooth. So these 2 points are supposed to be connected. They've got to be connected by my curve. This point's on the curve, this point's on the curve. They're supposed to be connected, and this one's below the x-axis, this one's above the x-axis. What must my graph do to connect those 2, where one's up here, one's down here, and they got to be connected? Tell me again. Ooh, I'm looking for the response. What happens if one's up here, one's down here, and they must be connected? Must you cross at least one time, must you cross across the x-axis to connect them? If one's below the x-axis, the other one's above the x-axis, they gotta be connected. They're on the graph. Must you cross the x-axis? Somewhere between 2 and 3. You've gotta cross the x-axis somewhere between 2 and 3. That means that's 0. That's an answer. If you can find that x-intercept between 2 and 3, you've discovered one of the zeros you're searching for. Michael, if I go through the possibilities, I'm gonna go now, and these possibilities, do I have one here that might fall between 2 and 3? And I'll test it, and it may work. Guys, does anyone have, no, 1 over 1 is not there, 1 over 6 is not there. I'm talking about something caught between 2 and 3.
5 over 2.
Oh, come again, I heard that.
5 over 2.
5 over 2, you said 5 over 2, that's a possibility. Oh, that's 2 1/2. 5 over 2 is 2 1/2. Does 2 1/2 fall between these two? Guess what? I'm guaranteed that's a 0. I'm guaranteed, but I know how to read the intermediate value theorem. Math is so nice. 2 1/2 has to work. Hang on. So I'll test 5 halves. Here, hang on to that thought. We'll take questions. Oh, by the way, is there another possibility about, with my possibility staring there, is there another possibility of a number falling between 2 and 3? He gave me 5 halves right quickly, I haven't tested yet. I'll see what Miriam's gonna ask. Miriam, do you see another one that may fall between 2 and 3?
5/3.
Wow! 5 halves, 5/3. Is there another one? Now wait, 5/3, does 5/3 fall between 2 and 3?
No.
No, that does not fall between 2 and 3, that's 1 point something. But is there another one that maybe I'm overlooking?
15 over 6.
Here we get it.
15 over 6, yeah.
15 over 6. Let's reduce it down. 15 over 6 reduced down by 3, what is that, 5? Is that 5 halves? Is that 5 halves again? You say 15 over 6, isn't that the same as 5 halves? I'm gonna test 5 halves. I'm almost for sure it's gonna work. Based on this sign change taking place here. I'm gonna test 5 halves. Here we go, 6. My number's 3. Negative 33. Negative 30. Here goes. 0. 6. Now I gotta be careful. This times this, I can cancel 2 and 6 to get a 3. 3 times 5 is 15. This becomes 18. 5 halves times 18. 2 goes to 18, what, 9? 9 times 5 is 45. Don't mess up now. Guys, what's this down here? 12? Is it 12? And if I do this, 2 goes into 12, 6. 6 times 5, 30. Oh, how cute. It works. It works. Michael, what it comes down to, you're gonna be so busy when you see one of these on the exam. Friday. You're gonna be so busy. But you're gonna get frustrated also. You're gonna say, Professor, I guess I'm gonna run out of time on this test. This test is so lengthy. My mind is all messed up here, Professor. I tested 2, I got this, and a frown on my face. It didn't work. I got more frustrated, Professor. What'd you do, Michael? I tested 3, darn it. I got this, it didn't work, Professor. I'm getting really frustrated. But I don't get too frustrated, because you see that sign change? One's above the x-axis, the other's below. This says, now, Michael, try something in between those two. If you can, if there's one in that set or there that's in between, and there was, in my case, what, 2 1/2? It worked. So I know you're gonna start testing, you're gonna get frustrated, but take note of what's on the end. So if you see a sign change, that tells you there's a 0 caught between. Now I'd like for a student to read that intermediate value theorem for me, for the class, and then I'll close this down. Who would like to read? Want to read? Jonathan, you want to read for us?
I'll read it again.
Oh, did we read once before? Barbara read that? Okay, oh, geez. So it works. Okay, so watch out for those sign changes. If you don't see a sign change, no, don't forget it. There's no answer, there's no 0 caught between. It's got to have a sign change between the two. Intermediate value theorem, all this in your mind, going on, you go half crazy. trying to do this. So I thought about this guy's closed down. By the way, I want to finish this up. 5 halves does work through intermediate value theorem. But left over is this. Let's find all the zeros. Left over is 6x squared. Yes. 6x squared plus 18x plus 12 equals 0. You guys agree with that? That's the leftover part? Yes. I could divide by 6 to reduce it down, to take out 6. Now it looks like that, I have no mistake. Then the red thing, this would factor, I think it factors. Yes or no? Split this up, you have another 0 to be a -2, another 0 to be a -1, and you are now finished. You have the zeros to be 5 halves, with the help of the intermediate value property, and then these two just came out, and those are your 3 zeros. Done. Done. Now, close it down. Oscar? Mr. Mathematician in the back there? Can you tell the class what might that now, that black, look like factored?
X minus 5 halves.
You know what, I'll put it, hang on, I'll put that down, there's nothing wrong with that, but I'm gonna show you something else, quick with that. X minus 5 halves,
X plus 2.
X plus 2,
Yeah. And X plus 1.
exactly right. Now, the only problem with what he gave me, the only issue, not much of an issue, but only issue. If you should now think, well, if I should expand that out, Professor, I should, in the blue, if I should multiply all this out, I should get the black. Guys, what was the first term, if I leave it the way Oscar gave it to me, and there's nothing wrong with that at this moment. But if I should multiply the blue out, anyone tell me what the first term in the expansion would look like? 1x cubed. X times x times x. I'm guaranteed the first term would be x cubed. We want 6x cubed. Now, can someone tell me, be clever, one little change we could make on Oscar's response, which was not wrong, but one little change I could make to ensure I'm gonna get a 6 this time. Jonathan, you think you have it?
Actually, I had one, but is it something like 2x minus 5?
Hang on. So now you're saying this right here, rather than what he gave, it could be written like this. Is that true? Yes, no? We do that?
And then multiply by
Hey, hold on. Yeah. Now, right now, guys, that would be 2x times x times x. That's 2x cubed, right? And what am I looking for? Was it a 6 in the original? That's true, guys? Was it a 6 in the original? Could I have done this? Boy, I don't want to throw this off. Could I have divided the original black by 3 to simplify it to begin with? And made this look like this? I think all those could be divided by 3. X squared minus 11x minus 10, but doesn't it look better? Now, am I guaranteed I'll get that 2x cubed that I want? Yes or no? If I had simplified that black first. If I had not, Jonathan, I think you said maybe place a 3 out front, and then that would guarantee 3 times 2 will eventually give me a 6. Okay, I just wanted to point that out, guys, to close it down. Intermediate value property. Watch out for a little sign change. If there is, there's a 0 caught between. In fact, there could be more than 1 0 caught between. Yes?
I'm so sorry, I think I spaced out. So how did you get the 2x to the third?
Right here, this. I'm just assuming the first, this and that. So if you multiply just the first terms together to see if you get this. I'm not gonna ask you to expand the whole thing.
Okay.
We at least get the first term, and I will. 2x times x times x.
That'll get us,
That's
are we
2x.
looking for six X?
Oh, beautiful, now, if you've been in that form, that was the original form.
Okay.
I've reduced it down later. Jonathan says if you wanna leave it in the original form, I think Jonathan, you said to do what, put a 3 up front? Something like that, and that would change it to 6.
Can we also just put a six in front of the factored form?
Yeah.
Yeah, okay.
Yes,
So can we just consider about the x, multiply the x to the power 3? We just want to make the x to the 6x to the power 3. So we can just multiply the 6 at the beginning.
oh, you could have.
Yeah.
Oh my goodness, my students, before we leave this. Are you saying 6 out here?
Yeah.
And he wants something to replace the 6 out here, I'll place the 3, the way we attempted this. You're saying there's a way to replace it by 6
Yeah.
and do it? That could be a way to do it. Guys, does it make sense though? I just want to point out that intermediate value property. Does it make sense when we got those answers? Those zeros? Whew. That's done. Chapter 3, for the most part, is done. Now I'm looking at the clock here. Or am I ever? This is the ending of chapter 3. Now there were changes. After you finally get in your head here, rational zeros theorem, Descartes' rule of signs, intermediate value property, complex conjugates. We have all that. That's only for polynomial. 80. Then all of a sudden they change it to a rational. They change it to a rational function. And before I pass this out, this one has no rational zeros theorem. This one has no synthetic division or substitution. We know. Miriam, this function coming up to closing out chapter 3 called rational, not polynomial, has no Descartes' rule of signs attached to it. But it's a function. And they're asked to now take a look at the graph of one of these types, and then we'll close this down. Guys, I'm not gonna be able to get through all this because I have more things to do with you. Got to pass out those extra credit. Oh, we half the class got the extra credit. I recorded it, not on Canvas, but I recorded it, because that means you're walking into the exam on Friday with 2 points already. So you have 2 points to help cover any mistake you might make on the exam Friday. Arena.